Mayong adlaw kanatong tanan, aniya na po kita sa atong tulumanon matag adlawng Sabado ug Lunes sa oras nga alas 3 padulong sa 4:30 sa kahaponon. Kini din yung ubos nga alagad, gawas nga ambungan buutan, ubos kong motindog, taas kong mulingkod. Lourence Araso Inanod po at your service. Palihog, paminaw, sabta kung unsa nga atong i-topic karon tungod kay importante kani sa atong pag-eskwela, labi na sa atong kurso nga mechanical engineering. Atong pagabatbatan tukion og utingkayon kung unsa manggaling ang grinding process karon. Apan sa di pa ako musugod, dako kay akong pagyukbo og pagtahod kang engineer sami tungod kay naghatag siya og gigayon nga makabuhat kita inani nga proyekto nga makadugan sa atong hibalo, makabaid alang sa pagtumpag sa bukid sa pagkaignorante. Ang dako kayo nga pangutana, what is grinding process? Unsa man gyud ang grinding process? Grinding is a material removal and surface generation process used to shape and finish component made of metals and other materials. The precision and surface finish obtained through grinding can be up to 10 times better than either turning or milling. Grinding employs an abrasive product, usually a rotating wheel, brought into control contact with a work surface. Actually, grinding wheel is composed of abrasive grains held together in a bender. These abrasive grains act as a cutting tools, removing tiny chips of material from the work. As these abrasive grains become dull, the added resistance leads to fracture of the grains or weaken of their bond. The dull pieces break away, revealing sharp new grains that contains cutting. The requirements for efficient grinding concludes abrasive components, which are harder than work. Shock and heat resistant abrasive wheels. And the third one, abrasive that are friable. That is, they are capable of controlling fracturing. When we say abrasive, the most abrasive used in industry are synthetic. The first on list is aluminum oxide. Aluminum oxide is used in 3/4 of all grinding operation and is primarily used grinding ferrous metals. This is aluminum oxide. And next, silicon carbide. Silicon carbide, which is used for grinding softer, non-ferrous metals and high-density materials, such as cemented carbide or ceramics. If there are abrasive, actually, there are also super abrasives, namely cubic boron nitride or CBN and diamond. These two are used in about 5% of grinding. For us to know, hard ferrous material are grounded with CBN, while non-ferrous material and non-metals are best grounded with diamond. The best thing we need to know is the grind size of abrasive materials is important to the process. Let's say large, coarse grains remove material faster, while smaller grains produce a thinner finish. But the benders that hold these abrasive grains together include vitrified bands, a glass-like band formed of fused clay or feldspar. Organic bands from synthetic resins, rubber, or shellac. And metal or single layer band system for super abrasive say. Oh, but wait. In wheel aspects, the first on list is wheels grading. Wheels are graded according their strength and wear resistance. A hard wheel is one that resists the separation of its individual grains. And that is too hard will wear slowly and present dull grains to the work and overheat, affecting the final finish. If too soft, a wheel is used, it will deteriorate quickly, requiring frequent replacement. Second on list is poor structure or density. Wheels grading is their poor structure or density, which refers to the porosity between individual grains. This poor structure creates space between the grains that provide coolant, retention, and areas for chip to form. Dense wheels are best for harder materials, while more often densities are better for softer metals. Want to remember the three factors of grain size, band type, and pore structure are closely related and together determine how a wheel will perform. Damaged wheels or even wheels suspected of being damaged should not be used. Safety steps for paper use of grinding wheels include, but are not limited to, first, always having machine guards in place before turning on a grinding wheel. Running wheels for at least 1 minute before actual work begins. Always using eye protection. Third, properly balancing and dressing wheels before use. When we say wheels, wheel dressing and throwing is done with special tools designed for that purpose. Although wheel dressing is often done manually between work cycles, some grinding machines perform the dressing task automatically. Do you know that application of coolants to the grinding process is important? Why? Because coolants reduce grinding machine power requirements, maintain work quality, stabilize part dimension, and ensure longer wheel life. Coolants are either emulsions, synthetic lubricants, or special grinding oils. Coolants are applied with either flooding the work area or by pressure jet streams. There are many forms of grinding, but the four major industrial grinding processes are cylindrical grinding, internal grinding, centerless grinding, and surface grinding. In cylindrical grinding, the workpiece rotates about a fixed axis, and the surface machine are concentric to that axis of rotation. Cylindrical grinding produces an external surface that may either straight, tapered, or contoured. The basic component of cylindrical grinder include a wellhead, which is incorporated with spindle and drive motor, a cross slide that moves wellhead to and from the workpiece, a headstock, which locates, hold, and drive the workpiece, and a tailstock which hold the other end of the work. The cylindrical grinding is a big machine that some of us don't know that it called about cylindrical grinding. Internal grinding. In internal diameter or ID grinders, finish the inside of a previous drilled rim or bored hole using small grinding wheels of high RPM. The principal elements of the internal grinding machine are the workhead, which hold the work, has its own drive, and it's the wellhead, which is the internal grinding spindle. In addition, The rotary motion of the work and well, an internal grinder has a transverse movement to bring the well to and from the work zone, and a reciprocating spindle movement for both well approach the work surface and work the feed movement the well during grinding. The internal grinder. The centerless grinding. In centerless grinding, the workpiece rotates between grinding well and a regulating drive well. The work is supported from below by axis work rest blade. There are two basic modes of centerless grinding: through feed and in feed or plung mode. In the through feed mode, that work proceed in the axial direction through the slowly narrowing gap between the grinding wheel and the regulating wheel. Work is advanced by axial force exerted on its by the rotating surface of regulating wheel. This is a highly productive form of grinding in that a number of workpieces can be ground simultaneously and in a continuous stream. The in-feed mode is used for work with projecting head that would prohibited through feeding. The work is placed on the work rest blade while on one well it is retracted and feed to an end stop. The well is then brought back, reducing the gap between the wells, grinding the work. The centerless grinding look like this. And the last types of grinding, of the four basic types of grinding I showed, is the surface grinding. In the surface grinding, produce flat, angular, or contoured surface of feeding work in a horizontal plane beneath a rotating grinding wheel. Work is most often magnetically attached to the table and may be ground by either traversing or rotating movement of the table. Most surface grinding machine use a horizontal spindle which adjusts up and down, allowing either the edge or the face of the wheel contact the work. And this is a surface grinder. Workpiece surfaces produced by grinding are influenced by the following factors. First, the workpiece material. Harder materials allow finer finish. Type of well. Fine grain shield finer finishes. Dressing procedure. Improperly dressing wells will mar the work surface. Feed rate. Finer finishes are obtained with slower feed rates. Machine rigidity. Older, worn machines yield a poor quality finish. Well condition. Clog wells cannot produce a good finish. And lubricant cleanliness. Coolant filtration remove waste that could damage workpiece surfaces. I hope these workpiece surfaces tips for you can help to have a good quality of grinding piece. Daghan kaayong salamat kanatong tanan kaninyong pagpaminaw niini atong tulumanon matag Sabado ug Lunes sa alas 3 padulong alas 4:30 sa haponon. Ako day usab si Lourence Araso Inano, dagapasalamat kaninyo sa paghatag og higayon. Sa English pa, lending me your eyes and ears, ha? Sa pagpaminaw, pagsaksi sa atong gipang tuki ug pangbatbat gipang istoryahan dinhi sa atong tulang mechanical engineering report. Okay. Sa usab kita-kits o ginaot kini makapatag sa atong kalambo, kabaskog sa lawas sama sa bulldozer o kalambo o palinaw sa pangutok sama sa computer. Daghang salamat. Bye-bye. Mama chup chup.